Assalamu alaikum everybody, my name is Yasmin, and in this video we'll be doing or going through the calculations we have for the IT7012 system analysis and design midterm exam. So let's start. Okay, we'll be covering these four topics: calculation for estimated expected duration, task duration estimate, critical path and slack days calculation, and at the end we'll look at how to determine sample size. So let's look at the first question first, which is how to estimate or calculate expected time or duration while looking at efficiency and interruptions. First thing we're going to do is you're supposed to read the questions very carefully and read the scenarios. Okay, efficiency is basically how much you can perform a task very well. And interruptions are how much you're disturbed while doing that task. So let's look at the question. A task can be calculated in 20 hours with efficiency of 100% and without interruptions. Assuming a project member efficiency of 80% and interruptions of 25%, estimate the time it would take for them to do the task. Okay. The first thing we're supposed to do always when you look at these examples is how much hours or the time it would take for them to do the task with efficiency of 100%, which is 100 here. Efficiency 100, look at the hour, which is 20. So I'm going to write here 20. And the person has efficiency of 80%. So I'm going to take the hours and divide it by 80%. So hours was 20 divided by 80%. Since I have percentage here, I have to convert it. So 80 divided by 100 is 0.8. So 20, which is the hours I have, divided by efficiency percentage, which is 0.8. Efficiency percentage. Let's calculate it. 20 divided by 0.8. This will give us 25. So it will take a person 25 hours to do it with 80% efficiency. Now we want to calculate how much it would take for them to finish this task with 25% interruptions. But before we do that, you're supposed to do one thing first. We're supposed to do 100 minus 25, which is the interruptions I have, 25. This will give us 75. This is a percentage, I have to convert it again to decimal number. So this will give me 0.75. Now I'm going to take this number, 25 hours, and divide it again on over interruptions. So 25 divided by 0.75, which we got from here. This is the interruption percentage. This will give us, let's calculate, 25 divided by 0.75, 33.33 hours. So to do a task which requires 20 hours with 100% efficiency, the person would take 25 hours, and then we have to calculate again with interruptions. With interruptions of 25%, it would take them 33 hours, 23 minutes to do the task. Let's look at another example so we can get a better idea of how to calculate it. First, we always look at how many hours it would take for us to do the task and divide it by efficiency of the person. Okay, so how many hours? It's 15 hours to do the task with efficiency of 100%. So 15. Efficiency is 85, so divided by 0.85. Let's calculate. 15 divided by 8.85. It would take them 17.64 hours. Now to calculate or look at interruption as well. So for that, 100 minus 25, which is here. This will give me 75%. This will be 0.75 in decimal number. I'm going to take this number or the hours I received, 17.64, and divide it by interruption percentage, which is 0.75. Let's calculate it again. So 0.64. 17.64 divided by 0.75. This would give us 23.52 hours. This is the final answer for this question. I hope this makes sense. If not, please repeat it. I can just go through the equation very quickly. So first you're supposed to do is the hours you have divided by efficiency. You get this number, let's say x. And then you take this x divided by interruptions, which you can get by 100 minus interruptions. For example, let's say 25, 75%, 0.75. So whatever the number is here, you're going to supposed to use it again here, 0.75. Calculate it. This is your final answer. I hope this makes sense. If not, please go to the slides again. Okay, so let's calculate here how much duration it will take for us to do a task, keeping in mind optimistic, pessimistic, and expected duration. Okay, so whenever you have this question, you'll be given three things. You'll be given optimistic duration, which is the minimum amount it would take for us to complete the task, expected duration, which is the time you need to calculate the task or do the task, and pessimistic duration is the maximum amount you need to do the task. And this is the formula you're supposed to memorize. Okay, so this is how it looks like. So to calculate it, we have 1 multiplied by optimistic duration plus 4 multiplied by expected duration plus 1 multiplied by pessimistic duration. Take the answer and then you divide it by 6. Okay, so let's put the numbers into equation. 1 multiplied by optimistic duration, which we have here, is 2, plus 4 multiplied by expected duration, which we have here, is 3 days, plus 1 multiplied by pessimistic duration, which we have here, is 6 days. 2 multiplied by 1 is 2, 4 multiplied by 3 is 12, plus 6 is 6. Let's calculate it. 2 plus 12 plus 6. This gives us 20. Now we're supposed to divide it by 6 here. So 20 divided by 6. Let's calculate it. This gives us 3.33 days. So for this, you're supposed to memorize the equation. So you can memorize it like a mnemonic, and you're supposed to put all of these numbers. So you can say 1O plus 4E plus 1P. So 1 multiplied by optimistic days plus 4E plus 1P. Just memorize it so you can use it for the exam, and then divide it by 6. Okay, now let's look at this question. This is not a question, but this is how to determine the critical path of any task or duration. Okay, so here I have been given 4 paths, which is 19, 18, 17, and 16. Path 1 has the longest duration, so it is the critical path, which is 19 days. Okay, so let's say, for example, you have been given a scenario in which the person decided to go with path 4. It would take them 16 days to do. So how many days can they delay this or these tasks without delaying the whole project completion? So you have to look at the path 1 or the critical path, which is 19 days. So critical path is 19 days. Okay. I with path 4, which is 16 days. How many days can I delay it without delaying the complete project? So this is always would be 19 critical path minus the path I have chosen, which is 16. 19 minus 16 gives us 3 days. So if I go with path 4, I can delay this or delay the duration of the path by 3 days without delaying the whole project. So whatever you have any question or scenarios like this, you're supposed to look at the critical path, how many days is that, and then subtract it from the path you have chosen, which can be any number given to you here, 16, 17, 18. And the days you get is the days you can delay the project completion without affecting your deadline. I hope this makes sense. Okay, let's start. In this slide, we'll be calculating the sample size. Okay, to determine the sample size, we'll be given the certainty factor. We'll be given desired certainty, and you have to calculate acceptable error. And then from that calculation, you have to figure out the sample size. So this is a formula you're supposed to memorize. See, so this part we're supposed to memorize it. Okay. So first we're supposed to look at is the certainty factor. and then the desired certainty and the certainty factor for it. So this is what we have. For 90%, you've been given 1.64. For 95, you've been given 0.960. And then from this percentage, which is desired certainty, we're supposed to calculate the acceptable error, which is basically just 100 minus desired certainty we have been given. In this case, we have 90, so we're going to do 90 here. See, this will give us 10%. We're supposed to convert it. This is 0.10. Okay, now how to calculate the rest of the formula? It's very simple. 0.25 multiply here, open the brackets, certainty factor which has been given to us. Just going to write it 1.645 divided by acceptable error, which is this number, 0.10 square here. I'm going to put this in calculator. Simple. 0.25 multiplied by, open the bracket, 1.645 divided by acceptable error, which is 0.10. Close the brackets. I'm going to put a square here. Power of 2. Okay, see, to calculate it again, 0.25 multiply by, open the brackets, 1.645 divided by 0.10, power of. This will give us 67.65, which rounded off can be 68, which is our final answer. Okay, let's look at another example, which has been given to us in the slide. Okay, so I've been given certainty factor, which is 95. We want to get acceptable error, which will be 100 minus 95. This is 5%. This is going to be 0.05. Then we're supposed to calculate the rest of it. You've been given certainty factor. Sorry, this is not certainty factor. This is acceptable certainty. Okay, so now to calculate, we're going to do 0.25 multiplied by certainty factor 1.960 divided by 0.05 square. To put this in the calculator, 0.25 multiplied by, open the brackets, 1.960 divided by 0.05, close the bracket, power of 2. The answer is 38.4.1. This is the final answer. This is how many samples I need to record to get the desired accuracy of 95%, which has been mentioned here. I hope this makes sense. Thank you for watching, and I wish you all the best for your midterm exam. Thank you.